Hello guys and welcome back to my channel Meet CISO. I hope you all are doing good. Today we are going to cover how to secure the data while it is in transit and while it is in use. So there are total three states of data: data at rest, data in transit, and data in use. In my previous video I have covered how to secure the data while the data is in rest mode. To access the video, click on the I button at the top right and understand how to secure the data at rest. In this video, we are going to cover on how to secure the data while it is in transit and while it is in use. So what is called as data in transit? Any data that is traveling in the network from one place to another place, from one device to another device, that is called data in transit. And while it is being accessed by the memory, that is called as data in use. So let's start with data in transit. So data in transit, from concept wise, there are two types of encryption that can help to secure the data, that is link layer encryption and end-to-end encryption. So link layer encryption is done at the data link layer and end-to-end encryption is done at the application layer. These two layers are a part of the OSI model. These are the seven stages or seven uh, layers of OSI model that starts with physical, data link, network, transport, session, presentation, and application. I'm not going in depth about this particular seven layers. If you want me to create a separate video on that, just let me know in the comment section. But coming to this, again, link layer is done at the data link layer and end-to-end encryption is done at the application layer. So what happens while the data travels from one place to other place or from one device to other device? While the data is in traveling mode, at that place, the data link layer, here you see the yellow lock is of data link and the blue lock is of application layer or end-to-end encryption, we can say. So the yellow locks open at each step or at each device, while the blue lock, which is the application layer lock for end-to-end encryption, that is blue lock and that remains locked during the whole journey from one step to another step. And the yellow one get unlocked, the header gets unlocked, router reads where it is going, then it goes to the other stage and then the third stage. So header gets decrypted, the header is written that where it is going and then it travels to the last or towards the last destination, where at the end the data link layer gets unlocked and finally the data reaches at the application layer where the final lock or application layer lock is decrypted or unlocked, we can say. So these are two types of encryption that guards the data while the data is in traveling mode. The most secure is link layer and um, end-to-end both, and they are both used in combination. It's not like only one types of encryption is used and other type of encryption is not being used. That's not the case. So both the encryption are used together to make the secure data traveling. Let's go to the next step, data in use. So guys, if someone asks you at which stage the data is most vulnerable, while the data is at rest, data is in traveling mode, or data is in use mode. So the answer is the data is in use mode. So data is most vulnerable while the data is in use. Why? Because the data definitely needs to be decrypted so that the memory can read, the OS can read it, right? So data must be decrypted and so that it can be processed. So memory is exposed and the clear text trap happens at data in use. So to get rid of this issue, we have come across confidential computing. That's a new standard, right? In which there is hardware based isolation as well as data while getting processed remains encrypted. That is called as trusted execution environment. Let's go through that trusted execution environment. What is that? That is hardware based isolation. And in hardware based isolation, physical partition memory from the rest of the system. That is created. The physical partition is done, and that creates an enclave that OS cannot read or OS cannot inspect. So that helps for the confidential data to be processed. Remote attestation is done. What is the use of the attestation? To ensure the data after process has integrity. So that is what the execution, trusted execution environment is. In simple language, you can say is that there's a separate partition at done. The separate partition is done for processing the data that enclaves the particular data and that even OS cannot inspect. And the second one is secure multi-party computation. So while cloud computing is increasing, so particular function is being used by multiple models. The inputs are secure. The input is private. No one knows the input and the function is being used. So multiple parties jointly compute a result, as I was saying, such as a model or static, without even sharing the raw or private data. So that's how the privacy remains intact while the function is being used by multiple parties. So these are the two ways by which we can even secure the data while it is in use. So how that can help? That can help in preserving privacy, and with the zero trust data ecosystem that is growing, and with that SMPC and TEE together, we can put the data in use even in the secure mode. So that is how we secure the data in use mode. Now let's test your knowledge. Which statement best highlights the difference between TEE and SMPC in secure computation? A. The TEE secures computation by isolating them in hardware enclaves, while SMPC distributes computation across multiple parties without revealing individual inputs. B. TEE ensures privacy by encrypting data during transmission, while SMPC relies on hardware isolation for confidentiality. C. TEE requires all parties to share the raw data, while SMPC requires a single trusted hardware enclave. D. TEE and SMPC both depend on centralized servers to guarantee security of computation. Second question, which statement correctly distinguishes link layer encryption from end-to-end encryption? A. Link layer encryption protects data only between directly connected nodes, while end-to-end encryption secures data across the entire communication path. Link layer encryption ensures confidentiality across multiple hops, while end-to-end encryption only secures local connections. Link layer encryption requires TLS, while end-to-end encryption relies exclusively on WPA2 and WPA3. Link layer and end-to-end encryption both operate only at the physical layer of communication. Guys, let me know in the comment section which is the correct answer for these two questions, and let's see whether you have understood the topic or not. And do let me know in the comment section on which topic you want me to make the next video. That will help me to understand what is the need and what do you need from me to learn and grow your knowledge in cybersecurity. Thank you and have a nice day. Please do like, share, and subscribe this video and share this with your friends. Thank you. Thank you all. Bye.